Okay, beta, the recording of the session is on now. So we will move on to this concept of running fix. Till now, what we have done in Chartwork is we have understood the concept of position lines. We discussed different methods with which position lines can be obtained. Then after that, we discussed the concept of position circles. We found out different methods with which we can obtain position circles on the chart. Now our ultimate aim is to find the position of the ship. So if there are one or two or one or position lines or position circles available to us, then we can combine them to find the vessel's position. Running fix is a concept which is used in combining the position lines or position circles. So we will first see the concept. What is the concept behind running fix? Then we will see using this running fix technique with a position line, and then we will see in the end using this running fix technique with a position circle. So let me set up the video.
Benefit the most from this video, kindly be comfortable with the concept of position lines, position circles, allowing wind, allowing current, allowing both wind and current.
Beta, is the picture and the audio coming in fine?
Yes, sir.
Yes.
Picture is clear, but audio is a little less.
Okay, you can maybe tune up your speakers, beta. You can increase the maximum volume. Let me check if I have some scope with me. No, I am on full. Maybe if you have a headphone, you can connect a headphone to the device.
Okay, sir. I'll do.
Okay.
Now, all these have been covered in the earlier videos in our series. If you feel that you need to brush up any of these topics, please do watch those videos before going ahead with this one.
Okay, so beta, these concepts are the ones which we have already covered. The position lines, the position circles, allowing and counteracting for current and for wind. These topics we have covered up. So when we understand and do this method of running fix, all these concepts will be used in the method. So whatever we have learned till now will be utilized in plotting a running fix question.
Be able to fix the vessel's position by simultaneous observations. That is, the observations which are taken at the same time. We must have minimum 2 position lines or minimum 2 position circles or minimum 1 position line and 1 position circle. Now, there may be situations wherein simultaneous observations are not available. However, staggered observations taken at different timings may be possible. These staggered observations may be in any combination. They could be 2 position lines, 2 position circles, or 1 position line and 1 position circle. Obviously, as the observations happen to be staggered, both these observations would be for different timings.
So beta, this is the scenario where the running fix concept is used. When we do not have 2 position lines or position circles available to us at the same time. So then we take a staggered observation. Staggered observation means one observation has been taken earlier, the second one a little later. Let's say, for example, you took a morning sight by longitude by chronometer method. No other PL or position circle was available at that time. So you waited for meridian passage of the sun and then you took a Marpas sight. Now this is a staggered observation. So the example which I gave you was of celestial navigation. Something similar can happen on terrestrial navigation also. So when we have these two different observations at different times, then they are combined together using this concept of running fix.
It is the displacement vector of the vessel over the ground. That is, her course made good and distance made good during the interval between the two observations is known. The first position line or the first position circle, as the case may be, can be run up or transferred to the time of second observation. The vessel's course made good and distance made good shall allow for the factors which are responsible for the vessel's displacement during the interval between the two observations. And these factors could be any one or all of the following. Vessel's propulsion vector, represented by course to steer and the engine distance covered during the interval. Wind, affecting its leeway, and the current affecting through set and drift during the interval. The intersection of the transferred PL or PC with the second observation, which again could be a PL or PC, fixes the vessel's position at the time of second observation. This method is known as running fix, wherein you have allowed the run of the vessel or you have run up first observation PL or PC.
So beta, any doubt up to here? Any doubt in any of the points? All clear up to here, beta? Okay, let's proceed ahead then.
The entire concept behind this is that whichever is our first observation, whether it's a PL or PC, we know the vessel is somewhere on that PL or PC. We are transferring that full thing through that interval. So obviously at the end of that interval, the vessel shall be somewhere either on the transferred position line or the transferred position circle. Learn about the transfer of position lines.
Okay, beta. So this was the basic concept of running fix. It is basically transferring the position line or a position circle. And this transfer is done by allowing for all the forces which are acting on the ship. The forces which are acting are the vessel's propulsion, vessel's own engine and the course being steered. The second force could be the wind, which will affect us in terms of the leeway angle. And the third force could be the current, which will affect us by way of the set and drift of the current. So all these three forces combined together, they result into the course made good and distance made good. And this is what we use for transferring the position line or the position circle. So any doubts up to here? All clear, beta?
Yes, sir.
Okay. So let's move on to the second concept then. The second is the transfer of position lines. So transferring position lines and then using this running fix method to find out our position. We will have different scenarios. One is a simple transfer where no external force is there, no wind, no current. Then we will involve the wind, the current, and both of them to see how the position line is transferred. So let me set up the video. Okay, beta, again for this video, the volume is little down. So if you have headphones, maybe you can use them.
Very good this one. Only straight line PLs can be transferred. Thus, this method does not apply to non-straight line PLs like that PL by depth contour.
Okay, so you can see the picture as well as the audio, beta.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
So we are now moving into transferring of position lines. The first thing to note is that in PLs, we had discussed a depth contour PL also, which was a random line. It was not a straight line. So this transfer does not apply to the depth contour. We cannot transfer a depth contour PL. All the other PLs can be transferred because all the other ones are straight line PLs. So let's see further what method do we use for transferring the PLs.
One method of drawing a unique straight line, as learned under the video on PLs, is to know a point through which to draw the straight line and the direction of the straight line. In context of the PL, this becomes a point through which to draw the PL and the direction of the PL. To transfer a straight line PL, we transfer any point on the PL. We take up any point of our choice, we run it up for the duration for which the PL has to be transferred, and the transferred PL is then drawn through this transferred point, and the direction of the transferred PL is the same as the direction of the PL being transferred of the first PL. The transferred PL is indicated on the chart by two arrows at each of its free ends with time to which it is transferred indicated against it.
Okay, so any doubt in any of the points, beta, on this slide?
No, sir.
Okay, all right, let's proceed ahead.
Now let us list down the methods for transferring the PL. So the steps are listed down in sequence. Take any point on the first PL, any point of your choice. Imagine the vessel to be at that point. Well, we know that we only have a PL, we do not have the position. Vessel could be anywhere on the PL, but we just imagine the vessel to be at that particular point, because then it will become easier for us to remember and execute the process. Determine the position where the vessel would have reached from its assumed position at the end of the interval for which PL is being transferred. The position thus obtained is the position to which the point on the PL, the assumed point on the PL, is transferred at the end of the required interval. Through this transferred point, draw a line parallel to the first PL. This line drawn parallel to the first PL through the transferred point is the transferred PL. Indicate the transferred PL with two arrows at each of its ends. Also indicate the time to which the PL has been transferred.
Any doubt up to here, beta? Okay, great. Let's see it on the chart then.
So now the only thing we need to know is how do we transfer the assumed point on the first PL. Of course, we take any point. The point can be any point of your choice. We imagine the vessel to be at that point, as already said earlier. Now, if we have to find the vessel's position at the end of the required interval, then we need to allow for the forces which cause displacement to the vessel. So all the displacement vectors or forces causing displacement of the vessel need to be allowed for. And what are these forces or vectors? One is because of the ship's own propulsion, represented by the course to steer and the engine distance. The other could be because of the wind, which is applied through its leeway. The other could be current, which gets applied or allowed through its set and drift. Now, in each case, you may be experiencing either one of these factors, two of them, or maybe all of them. So depending on how many of these are applicable in a given scenario, we allow for that many factors and find out the position where the vessel would have reached from its assumed position on the first PL. The position thus obtained is the transferred point. For to transfer the first PL through this transferred point to obtain the transferred PL.
Okay, so this is the basic method which we follow by taking any point on the first PL, then applying all the forces which we have, that is the engine distance, engine speed, core steered, wind and the current. So then we transfer this position, and once the transferred position is obtained, we draw a line parallel to the first PL, or we transfer the first PL through this particular point to obtain our transferred position line.
Now let's look at this entire exercise through some examples so that we allow for these factors in different combinations. A vessel steering 070 degrees true at 12 knots observes Roche's Point light bearing 010 degrees true at 2000 hours. At 2130 hours, it observes Ballycotton Island light bearing 320 degrees true. If there was no wind or no current during the interval, find the vessel's position at 2000 hours and 2130 hours, CMG and the SMG.
So beta, is the question clear? Any doubt in the question?
No, sir.
Okay, very good.
So we start with the identification of the landmarks. So here we have identified this is Roche's Point and this one is Ballycotton Island. You can see where these boxes are coming. We draw the first PL of 2000 hours. This is the first PL. We draw the 2130 PL, indicated time against it. Now we pick up any point on the first PL. So this point A is any randomly selected point on the first PL. Now the vessel is experiencing displacement only because of her own propulsion, as the problem statement says no wind and no current. So through A, we draw CTS. This CTS is represented by single arrow, you can see. The magnitude of this vector shall be the engine distance for 1.5 hours, interval between 2000 hours and 2130. So at 12 knots, the distance becomes 18 miles. So from A, we mark off 18 miles and we get point B on the CTS line. Now B, we all know, would be the DR position of the vessel. But in this particular case, since there is no wind, no current, so this also happens to be CMG line. So you can see two vectors coming up on this line. So this is CTS as well as CMG line. And distance AB is the engine distance and also becomes the distance made good in 1.5 hours. So because vector AB is CMG line and distance AB is the distance made good, so point A is transferred to point B. So through B, we transfer the first PL. You can see it here. The transferred PL in red is represented by two arrows at each of its ends. You can see time for 2130 indicated against it. So now we have one transferred PL for 2130 and we already have another PL for 2130 where they intersect. This becomes the vessel's position at 2130. So point X represents the position of the vessel at 2130.
Okay, beta, up to here, the procedure is clear. Any doubt you are having, please ask me.
No, sir.
Okay, very good. So we have obtained the 2130 position. Now the other thing which is asked is the 2000 hours position.
Now, how the vessel would have reached this point X? Vessel would have reached point X by making good a course whose direction is represented by AB, CMG. So that means the vessel would have reached point X by traveling over a track represented by AB direction and passing through point X. Now this one. So that means the vessel would have basically traveled along this track, which is the CMG track, and at 2130 reached out here. So that means the vessel would have been here at 2000 hours. So where this CMG transferred through point X cuts the 2000 RPM, this becomes the 2000 hour position. So point Y is the fix at 2000 hours, point X is the fix at 2130, Y to X direction represents CMG, and distance Y to X represents distance made good in 1.5 hours. When this distance made good is divided by 1.5 hours, it shall give us the speed made good by the ship in knots.
Okay, so any doubt up to here, beta? The plot is complete now.
No, sir.
Sir.
Okay, all right. So this is the basic running fix concept. So we have fixed the ship's position at 2130. Now, one variation which could be there in the question is, in this particular question, we had the PLs from different lighthouses. You see, one was from Roche's Point, the second one was from Ballycotton Light. So it is possible that they may give you the bearing of the same light also after a certain time. So the question can be put up by giving the bearing of the same light also. That's a variation which could come in the question. The procedure remains exactly the same. Let's proceed ahead now.
In this case, of course, CTS and CMG are same, engine distance and distance made good are same. Why? Because there was no wind and no current. So you can see other notations also showing up. Let's take another scenario. Vessel steering 070 degrees true at 12 knots, observes Roche's Point light bearing 010 degrees true at 2000 hours. At 2130 hours, it observes Ballycotton Island light bearing 320 degrees true. Same as before. If during this period it experienced northwesterly wind causing 3 degrees leeway but no current, find the vessel's position at 2000 hours and 2130 hours, CMG and SMG.
Okay, so beta, in this question you see the question is exactly the same, only with one difference, and that is the wind is now present in the area. They have given us the wind direction. We have northwesterly wind. They have given us the leeway angle also, so 3-degree leeway. So now we will see this procedure with wind. Rest everything is same as what we did earlier.
As you can see in this question, that we'll have to allow for ship's own propulsion vector, and also we'll have to allow for wind. So let us see how do we allow for the wind, which we've already covered earlier under allowing wind and current. But let's quickly allow for wind and proceed with the question. So we identify the two landmarks, of course. These are the two PLs, which we have already covered in the first discussion. We take any point. Now this light green vector which you see is the CTS vector 070 degrees true. Vessel is experiencing northwesterly wind, that means wind is coming from northwest. So northwesterly wind would be as represented by this arrow, wind arrow now in the diagram. Now since we have to allow for leeway, please remember we have to allow for leeway. When we allow for leeway, leeway is factored or allowed to the lee side of the vessel or to the downwind side. In this case, you can.
So beta, can you tell me what will be the leeway track or the effective course in this case?
073.
073.
Very good. Very good.
You see the starboard side of the ship is the lee side, so the leeway is factored onto the starboard side. You can see 3 degrees of leeway showing up on the screen, and what you get with dark green line is the leeway track or the effective course track. which is also represented by a single arrow. And you can see in this case, the leeway gets added to CTS, give us the effective course.
Now, as I told you earlier also, beta, usually when we do chart plotting, the leeway angle and the course steered is not shown on the chart. We only show the effective course or the leeway track. So in this particular case, we will only be showing the 073 direction vector. The course to steer and leeway angle is not shown because leeway angle is usually very, very small. It could be 1, 2, 3 degrees in this range. So when you draw it on the chart, the plot may get cluttered. So you can just show this working on your answer sheet that my CTS was 070, leeway 3 degree, wind direction northwest. So that's how I got my effective course of 073. And then you can straight away plot 073 on the chart.
As also explained in the video on allowing for wind and current, on chart we may prefer not to plot both these vectors because they will unnecessarily clutter the chart. So if you wish, you may allow for wind on the answer sheet, as you can see the steps showing up in the box. CTS 070 degrees true, leeway 3 degrees northwesterly wind. Why the wind direction is being reiterated here? Because it has to be seen in conjunction with the CTS to decide whether leeway is to be added or subtracted. And so the effective course becomes 073 degrees true. So what we'll do is we'll restart our plot, and instead of drawing CTS, we'll draw the effective course of the leeway track of 073 degrees true. And of course, the magnitude of this, as already explained in the earlier videos, would be the engine distance for the required duration. So now we start with the effective course of 073 degrees true. Landmarks identified, both PLs plotted on the chart. We take any randomly selected point on first PL, and this time what we draw through point A is the effective course of 073 degrees true. This will also be represented by single arrow. The magnitude of this would be the engine distance for 1.5 hours, that is 18 miles. We get point B. That means the vessel from A would have reached point B after 1.5 hours because she would be moving along her effective track. So this also happens to be her CNG line. So point A, as already explained, is transferred to point B. In the previous discussion, where there was no wind, it was a 070 degrees true into 18 miles track. This time it is 073 degrees true into 18 miles. Point B is to the point to which A is transferred. PL is transferred through B, marked with 2 arrows at each end. Time of transferred PL indicated, and this is the 2130 fix, X is 2130 fix. Now the CMG line represented by AB transferred through X, giving us position at 2000 hours, that is point Y. So Y is the 2000 hour position, X is 2130 hours position, Y to X direction is the CMG, which is 073 degrees true in this case, and Y to X is the distance made good in 1.5 hours, which will lead us to speed made good.
Okay, beta. So this plot is also completed, the running fix with wind acting in the area. So just have a good look at the plot. All the symbols which you are seeing. So these symbols should be shown on the chart. That's very, very important. You see the transferred PL is indicated by double arrows, and you also have the time written with it. The position is represented by a circle and a dot with the time mentioned along with it. So all these things should be mentioned in your plot. So any doubt up to here, beta?
So one question, sir.
Yes, sir.
बोलो बेटा.
सर जब खाली विंड का इफेक्ट होता है, जैसे इसमें खाली विंड का इफेक्ट हो रहा है, तब स्पीड पे कोई इफेक्ट नहीं पड़ता ना सर, जो स्पीड में कोड अपना आएगा?
That's right, beta. हम विंड का स्पीड पे कोई भी इफेक्ट कंसिडर नहीं करते हैं. So there will be no effect on the speed. The length of this vector which we have chosen will be our engine distance for 1.5 hour, 2000 to 2130. It will be engine distance only.
ओके सर.
सर एक और बात.
हाँ बोलो बेटा.
सर अगर इसी जैसे नॉर्मल इस क्वेश्चन में अनटिल अनलेस अगर एक साइड की फिक्स हमें गिवन ना हो तो हम कॉन्ट्रैक्टिंग करंट नहीं लगा सकते.
You mean to say fix is not given. Fix तो बेटा दी ही नहीं है इस क्वेश्चन में.
मैं इन जनरल पूछ रहा हूँ सर. फिक्स जैसे नॉर्मल क्वेश्चन है सर, उसमें अगर हमें बोले कॉन्ट्रैक्टिंग करंट है तो उसमें हम कैसे करेंगे? नहीं होगा सर.
Okay. You mean to say they have given you a question for counteracting a current.
करेक्ट.
Right. अगर वो आपको करंट काउंटरएक्टिंग का क्वेश्चन देंगे तो बेटा इनिशियल और फाइनल पोजीशन दोनों उनको देनी पड़ेगी.
कैसे तो रिपीट करना है?
If they give you a question on counteracting wind or counteracting current, any one of them, they will have to provide you with the initial and final positions.
सर इनिशियल फाइनल चाहे ना भी हो, दोनों में से एक हो, हम उस पे सीएमडी ट्रैक मार देंगे, फिर उसके बाद कर
नहीं
लेंगे. और
नहीं 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 बेटा, अगर आपको सिर्फ एक पोजीशन दे रखी है, लेट अस से दे हैव गिवन यू द स्टार्टिंग पोजीशन, how can they tell you to counteract the current till the time your destination is not known?
नहीं सर, हम अज्यूम कर लेंगे ना दूसरी लाइन पे, वो बाद में जो हमारा एक्चुअल सीएमडी आएगा उसको फर्स्ट पॉइंट पे ट्रांसफर करेंगे, जब वो सेकंड पॉइंट की ऑटोमेटिकली दे देगा. हम
Okay.
बाद में सेकंड पॉइंट की तो अज्यूम कर सकते हैं ना, एनीवेयर ऑन समवेयर, किसी भी लाइन पे. फिर बाद में जब हम सॉल्व आउट करेंगे सीएमडी निकाल के, तो वो बोल सकते हैं व्हाट वी अज्यूम इज रॉन्ग, और निकालने के बाद ये है.
नहीं बेटा, मैं तुम्हारा क्वेश्चन समझ नहीं पा रहा हूँ. तुम एक बार फिर से मुझे बताओ कि डाउट कहाँ पे आ रहा है.
सर अगर हमें कॉन्ट्रैक्टिंग करंट दिया हो और उनमें से उसके लिए हमें एक मिनिमम, दोनों में से साइड में से एक फिक्स चाहिए, करेक्ट सर, या दोनों चाहिए?
दोनों चाहिए बेटा. या तो दोनों फिक्स चाहिए या सीएमजी चाहिए. सीएमजी वेक्टर चाहिए या दोनों फिक्सेस चाहिए, इनमें से एक चीज चाहिए बेटा. इफ देयर इज ए काउंटरएक्टिंग क्वेश्चन.
तो जैसे अभी एक साइड से दिया उन्होंने, हमें एक स्टार्टिंग की फिक्स दे दी और हमें एक सीएमडी ट्रैक दे दिया, उसको हमने
Okay.
एक्सटेंड कर लिया. दूसरी साइड फिक्स पे वो आर्बिट्रेटरी कहीं भी जाके काटा हो, किसी भी लाइन पे काटा, फिर इनिशियली हम जो उसको लगा रहे हैं उस पे कॉन्ट्रैक्टिंग करंट करके, फिर उसको फर्स्ट पीएल को जब ट्रांसफर करेंगे, वो ऑटोमेटिकली दूसरी साइड बाइसेक्ट नहीं करेगी दूसरी पीएल पे.
नहीं बेटा, ऐसा क्वेश्चन बनेगा नहीं. वी विल कीप ऑन कमिंग अक्रॉस दीज टाइप ऑफ क्वेश्चंस. सो जैसा तुम बता रहे हो, आई डोंट थिंक दैट काइंड ऑफ क्वेश्चन कैन बी क्रिएटेड. देयर कैन बी कॉन्ट्राडिक्शन बेटा. इसमें ना ओवर इन्फॉर्मेशन आ गई तुम्हारे क्वेश्चन में. सो जरूरी नहीं है कि वो वहीं पे काटे. इट कैन गो अवे फ्रॉम द पोजीशन लाइन ऑल्सो. सो आई डोंट थिंक दिस टाइप ऑफ क्वेश्चन कैन बी मेड. इफ यू हैव एनी क्वेश्चन, so you can just share it with me.
नहीं सर, ऐसा है नहीं क्वेश्चन, मैं बस सोच रहा हूँ.
Okay, I am doubtful that this kind of question can be made better.
समझ गया सर, अब क्या बात.
Anyway, we will come across many more questions going ahead. So let's see if something matches with this. Or what you can do is, the way you are thinking that this kind of question could be there, just put down some hypothetical values and send it to me over WhatsApp. Let me have a look.
ठीक है सर, मैं देखता हूँ.
Okay. Okay. So this was running fix with wind. So we have seen the transfer of the position line with the wind present in the area. So let's take a break, and after the break we continue with the introduction of current also in the running fix question.
Okay, sir. Thank you.
Okay, beta. So see you back at 11:30.
Okay, sir.
Yes, sir.
Okay.
Okay, sir.